Hi, my name is Francesco, and this is a very quick introduction to Unreal Engine 4. Unreal Engine is an extremely powerful engine program, game engine, television, film, software, architectural design software. It does a lot of stuff, but we will be using it for game development. So it is a game engine. What is a game engine? It's just a software that has a bunch of code that can do a bunch of calculations. It has a bunch of built-in functionality for graphics, for physics, and it makes it really easy to just jump in and create a new game. So my goal is to kind of break down the myth that Unreal Engine 4 is really hard to get into and kind of break down different components of Unreal Engine so that you have a better understanding of how to make something like a fun little game. So when you enter Unreal Engine 4, this is the first window that you'll see. We're gonna start with games, and we can start with third person. These are just templates for different games that you can do, and we'll just start with that. Everything else can stay the same, and I'll just start with starter content, which just means that it has a bunch of textures and materials and effects and audio clips, which can be used to make your game, but you don't need to do that if you have your own material. I'll just call it test game because it's a beautiful test game, and we'll create the project. You may have a different version of Unreal, that is totally fine. Future versions of Unreal Engine 4 will just have more features. Hopefully the interface will still be similar to this. So it can be a little intimidating when you see all of this stuff. It's kind of like, what am I looking at? So I'll kind of go from left to right, explore like the different sections of Unreal Engine. So first of all, we have this modes window, which has a bunch of different panels, which can be very intimidating at first because I don't know what any of these do. Well, most of these are just things that you can drag into the world to kind of create things. So going into the center, this is the viewport, which is the actual 3D world. So if you move the camera around, right-clicking, you can kind of see the world itself. If you drag a cube down, this cube now exists in the 3D world. So if I rotate the camera using WASD and holding the right click, you can kind of see that this cube that I put here actually exists in the 3D space. I can I can add a point light, I can add cylinders, I can add pretty much everything that's in here. Spotlights, which are just different types of lights compared to point lights, and so on. In terms of paint, this is used for painting surfaces. You can also use it to use a Foliage tool, which is very similar to the paint, but for Foliage, pretty much we still use the word painting because you technically are painting grass, and you can kind of use a brush to literally paint 3D grass, which makes it really fun to create these worlds. And a landscape tool, which as you can see is about, although I'm not gonna click create, it's about to create a huge grid, which you can then modify by raising and lowering, meaning creating mountains and lakes. But for now, we're gonna keep it very simple. We're gonna just stay in this very small world. On the top, you have different options. What you really need to know is just save current. Source control, if you're not familiar with development, this is just a way to kind of upload your code online so that other people can download it and you can kind of work together and collaborate on the same project. And then the other one is build. If you put lights, you may want to build them so that the engine knows that certain lights will always create a specific shadow. For example, the sun right now is not moving, so things like this cylinder will not be moving because I'm not attaching any code to it. And as you can see, is a static object, meaning it will not move. And so the engine can kind of bake or calculate the shadow created by the cylinder and save it to save some processing power instead of constantly every frame calculate the shadow of this object. This is why I just put new lights in, and it says that some lighting needs to be rebuilt. Clicking this icon or clicking this specific build lighting only will allow the engine to build that lighting. And then play. You have different options to play. You can play in VR. You can create a new window, simulating to be kind of a game in its own, or you can just play from the viewport. This means that if you play, you are now in the game. This is the viewport became the game itself. You press escape and it takes you back to your sort of editing mode. There's a lot of options here, but none of them are super important. This kind of changed the perspective of the world, and you can change it to be wireframes, unlit, detail lighting. Usually lit is how people keep it, or unlit. And then this is some scaling options, but none of it is super important for the time being. On the right side, you have a world outliner and levels. We're gonna just focus on the world outliner. This is just a list of objects that exist in the game. So everything that you've dragged in, like this cube, is part of the world outliner. You can put it into subfolders if you think that's better for you. You can inherit it so that it kind of becomes a child of you can indent it so that it becomes a child of another object, so that if you move one object, it moves the other one, and you can also just keep it its own object. In levels, these are different levels. You can create sub-levels that you can stream in and out to load them and unload them, but for now we're just going to keep a persistent level. Every time you select an object, it has a bunch of parameters, which is extremely overwhelming. It has components with different parameters, but this right now is not super important. The major part is that when you click on an object, it has a location, rotation, and scale. Scale meaning, you know, the size of that object on that axis. Static meshes is the 3D model, and the material is the sort of texture applied to the model. Everything else for now, we're going to keep it sort of unknown, and we're going to dive into it later. At the bottom here, you have a content browser, which is what the project has. So you have animations for the player, because the player can breathe in idle, can walk in different directions, can jump. And all of this require different animations. Depending on the state of the player is now idle, so it changes to a different animation. I'm pressing W, which means I'm going forward, playing a specific animation, and I'm jumping, playing another animation. Other than that, we have the starter content, which is what I added originally, which is quite heavy if you look at it from a gigabyte point of view. But it contains a lot of, default sound. It contains some maps, which is a level, an idea of a level. It contains props, which is a static mesh. So you see here it says in the parentheses on the top right, static mesh. It's just a 3D model. And then textures, which you can then drag to things to create materials. Materials are very particular. If you click on them, you're going to see all this very confusing stuff, which basically is just, an editor used to change the way that the color, the metallic surface, how specular it is, the roughness, the emissive color, and so on, of this material looks. It doesn't change anything else but the look of the object that you apply this material to. So this material can be dragged onto anything, and now that object, that static mesh, gets that material. Now some of them look very bad, other may look a little bit better. Now this looks like an ocean, there's steel, there's all kinds of stuff. That didn't change anything of how the material, the model actually functions. It's just the way it looks. So even if this is water, I can still walk on it because the collision didn't change. and the model is still the same. You can create new materials by importing textures and then creating a material out of that by simply right-clicking, create material. Unreal Engine will take care of the rest. You can then modify the roughness, you can modify how reflective it is, and different properties of the materials. So now we'll get into how to create a very, very simple blueprint. So blueprints are extremely powerful, sort of lightweight actors or entities in the game that you can attach script to it, meaning you can attach functionality. So if you right click and you create a new folder and we call it blueprints, you don't have to call it blueprints, but I like to call it blueprints. You can then enter it and you can right click again to create a bunch of different stuff. You can create particle system, meaning effects, like special effects, materials, levels, meaning maps, and blueprint class. A blueprint class is pretty much an entity. Just think of it as an entity that has different functionality depending on what you want. The default one is sort of actor. Actor has a bunch of functionality built in that you can attach to, you can interact, you can modify. There's different things like player controller. Here it has a description, but if it doesn't make too much sense, don't really look too much into it. Most of the things that are important are widgets, which are sort of, think of it as like 3D interfaces or text floating. If you want text to be floating, you can think of it as a widget. Or we'll just stick to actors for now. So let's say I want to make a cube, and this cube, we'll call it test cube, and we will drag it into the world. And right now it looks like this weird sphere. This sphere actually is nothing. If I start the game, this sphere doesn't exist. It's nowhere to be seen, although it is technically here. This is sort of just the scene root of the blueprint. It kind of like the engine telling you, hey, there is this object here. But the object actually doesn't have anything else other than its root. So if we want to make it a cube, you can add a cube. And you're going to see that as soon as you make a change in this blueprint, it does a change in the actual world. So you're creating an instance of a blueprint, meaning that anything that you do to the blueprint will actually be replicated to each instance. So if I make another cube and I move this cube in the blueprint, all of them do that. But if I individually select a instance, that instance will be the only one changing. And I can compound those changes by doing one change on an instance and changes on the blueprint itself. So that makes it, very interesting. So if you want to try to do something that let's say you're trying to make a monster, and that monster, you want the player to run into it, and then when it runs into it, it will give a point to the player. The way that this stuff works is that everything works with collisions. So the game thinks of everything as a collision. It doesn't really know the 3D volume of it, how it looks. It will just look at its collision. If we look at the first person character, we can see that it has what's called a capsule collision, which means it's a capsule looking collision. The game will really not care a lot about how the player looks in terms of functionality. As long as the capsule collision is on the ground, the player will be on the ground. If this capsule collision falls, the player will look like it's falling, but it's really just a capsule collision not hitting the ground. Why do they do that? The main reason is because computation power. Since the first few games, collision, it's always been sort of summarized with very, very simple shapes. For example, squares or circles, triangles, that kind of stuff. Usually the most famous ones right now are cubes and capsules or spheres. And those in fact are the type of collision that you can find if you want to add a component. Those are the ones that you find here. So if you want to have the player collide with the cube and the player gets a point, all you have to do is create a collision for this cube. And when the player walks into that collision, they will get a point. So I'll do a box collision, calling it box, and I'll make sure to make it a little bit bigger. The way you do that is with all this menus that you see up here, you can actually switch between different things like moving it, rotating it, and also making it bigger or smaller. We'll make it like this. So right now the box collision is a little bigger than the actual cube. So if the player just walks and its capsule collision touches this box collision, the code that you create will actually run. How do you test this? Well, in box collision, you want to go all the way to the bottom in events, and you will see different events that can happen. So let's say you're on mobile and you want the player to click on something. Well, you can attach a collision, and if they click on it, then that's what happens. If they release their finger, another thing can happen. Actually, sorry, I think it's called touch begin and touch end. Clicked, it's actually with the mouse, not with the finger. But what matters for us in the game is on component hit, begin overlap, and overlap. On hit means every, let's say frame, it's not an accurate description, but let's say just frame. It will check if the player is touching this collision, meaning it's on it, or the capsule collider is right at the border, touching the box collision. Then we'll run some code constantly. Begin overlap means it runs only once when it touches, and end overlap, it runs only once when it stops touching the collision. So if I want to do a begin overlap, what I could do is just print a string called hello. These white lines are logical connections. So meaning that if I remove it, pressing Alt and clicking it, now every time the player will collide with the box, nothing will happen because there's no collision. There is no logical connection. If I connect them, now it will it will execute the code that's on the right side from this connection. So it will just print hello. So if I save, compile and save, I can now play. And if I run into this box on the top left, you can see hello. And you can see that it's printing multiple times. And it is because the capsule collision on the player is walking into the box collision. It doesn't happen exactly when you walk into the cube literally, but there's an invisible box collision, which is the one that we put, that as soon as I walk into that, it will print it. It's printing multiple times because it is looking at this box collision, not the box itself, not the cube itself. And so I was running into this invisible place that was printing hello. You guys see that? But if I walk into the cube, nothing happens because there is no collision on it. Now there's a block collision, as you can see. I can't walk through it because Unreal thinks that, by default, if you're putting a cube there, you probably want some sort of very simple collision. And you can see here that the collision on this cube is block all dynamic. Now I'm diving a little bit into this, all these options, but for example, if I say no collision, you guessed it, I'll be able to walk through those cubes. Now I can still say hello because the box collision is different from the actual cube, but I will be able to walk through the cube because there's no collision on this cube. There's nothing. This cube is literally just a visual entity at this point. So now that this happens, we probably want to do something like giving a point to the player. So a very simple way to do this is to edit the blueprint of the player. How did I get here? You can click on the character and go and edit third-person character. But if you're also trying to get the character, you don't remember how it's called, you can search for third-person character, you can search for character, whatever name this blueprint has. By clicking on it, it should tell you what it is, and then you can search it manually in the content browser. Now, this is the whole code that's governing the player input. There's a little extra stuff like VR, there's extra stuff like mobile input that we don't actually need in this 3D PC version of it. But just keep in mind that you can have multiple versions for different consoles, different input styles running on the same blueprint, and that's fine. The engine will know how to take care of it. So in here, what we want to do is create a bunch of code called event. There's functions and events that will give a point to the player. Functions are a little bit more complicated than events just because they have a return type. If you're not familiar with programming, just stick to events for now. Events are that you can do pretty much everything that you want to do in events, and I just personally like working in events. So if you right click anywhere, you can now see all the functionality that this game engine has built in, which is a lot. It's massive, it's extremely powerful, and it's actually fairly easy to use. So you can right click, and we want to create a custom event, meaning let's create a custom bunch of code that will increase points. This meaning that the player will hold a certain amount of points, and we just increase that variable. So down here in variables, we can hold that amount of points by creating points and changing the variable type to an integer, meaning just a number. If you're familiar with programming, I'm probably going slow, but I just want to make sure that I cover all the points. No pun intended. Anyways, with points, you can now drag the points in, and you can get or set. You can also holding control and holding alt. You can get the points and then add it to it, sort of a +1, and drag that into the set, connecting the logical connection. So now you have a name that refers to a bunch of code that is called increase points, which will set the points to the original value +1. That's your new points. So every time I call this, it will go from 0 + 1 is equal to 1, set that to points. Next time I call it, points is 1, because I just set it to 1. Now the 1 + 1 is 2, set that to points. And so I can call this as many times as I want, everywhere in the code, whenever I want to give the player points. Because this happens behind the scenes and you can't really tell, I like to print stuff just to make sure that I'm aware of things changing and I can see it from the viewport. And so I like to print points just to see, okay, is this code actually running? Because there's no visual clue that happened other than behind the scenes points increasing. Now this function is created, but it's never really called. Or this event, sorry. It's created but never called. And so I want to be able to call it here. Basically what I'm trying to do is tell, and this is the most complicated concept that we'll talk about today, is telling this cube, hey, go into the player and increase the points. To do that, we do something called casting. So other actor is the actor that's colliding with the box collision. The overlap component is the component of this blueprint that gets overlapped, in this case box. Other actor is the actor, the blueprint actor, third person character. We can do something called cast, and we can cast to the third person character, meaning let's go into that blueprint and let's do some stuff there. the reference of this object is the actor itself. So we're saying, hey, the object that we're trying to cast to is that actor, that third person character that overlapped with the box. Now that we have a reference, this blue node, now that we have a reference of the player, let's increase points. That's it. That's the whole logic. So the player collides with the box. It will check, is this the player? Yes, because the player knows that it collided, but the cube doesn't really know what collided with it. It could be a million things. You need to make sure that it's the third person character that collided with it. If it's true, if the cast didn't fail, increase points. If the cast failed, means that this box collision was triggered, but it was triggered by something other than the third person character. So if you have multiple things in your game that are supposed to collide with this box, you can then from here check if if the actor was something else, cast into a pet or an animal or a monster or something else, a bullet, whatever your game has, you can check that there. But for now, this is literally all the functionality that we need. What now will happen is that increase points will be called, set the points +1, and print it. So every time I collide with this box collision, which right now is in front of me, now I get 1 on the top left. You see that little blue one, which is now 2, 3. I'm walking purposely in and out because I know where the collision is, and points are increasing. If I walk into the cube, it's 8, 9, 10. And this variable is held into the player. It's not dependent on the cube. So it's not that each cube has their own variable that independently raise and go up. It's only the player. As if we had 2 different players, one of them will be staying at 0 and one will be staying at 1, 2, 3, 4, and so on as we walk into these cubes. So I know that this was a lot. I hope that this was a pretty good introduction to Unreal and just how blueprints work. You're able to now use collisions to kind of trigger different events and decide when players get points. You know how to create a variable, points, and you can create one called health that gets subtracted if they walk into something like fire, or if they fall down really fast. Different things you can do. You're able to navigate in the menu and navigate to different blueprints and understand kind of how to create a very simple event, very simple group of code that can do something that is relatively simple but has a ton of potential. You also understand that cubes or blueprints in general are objects that you can create instances of, and you can create as many as you want, and you can modify them individually if you want to, or you can modify them as a whole. So all the ones that haven't been modified individually, you can actually go in and change them for all of them. That's it, guys. Thank you so much, and I'll see you in the next tutorial.